Hello everybody. This week we have started discussion on shift register. So, in the last class we have seen parallel in parallel output option for register as well as serial in and serial out. Okay. So, in today's class we shall look at serial in parallel out SIPO and parallel in serial out PISO, how are they used and how they look like, and also universal shift register. Okay. So, this is what we are going to discuss today. So, we start with a practical circuit which is used in the IC packages IC 74164, which is a serial in parallel out shift register, register. Okay. Register, as I said, group of flip flops which stores binary information that we have seen before, and if it uses shifting option from one flip flop to another, where input of one is fed output of one is fed as input of the other. Okay. So, that is shift register operation. Okay. So, if we look at this circuit, it is a 14 pin package. Okay. So, you have got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, 8 flip flops. So, 8 serial in parallel out. So, this QA to QH, A, B, C, D, E, F, G, H. So, 8 outputs are there. So, you can read it as many times as you want. Okay. There is nothing like destructive reading and all, through where serial out reading through serial out is there. Okay. And these but the data is written serially through serial input. Okay. So, in one you see that these are the two inputs. So, one of them you can consider as a control input, say B. So, when this is low, right. So, this particular input over here will always be low. Okay. So, S input will always get low. Okay. And R is always inverted version of R. Okay. So, that is the way we usually store the data, right. Effectively, this one is D flip flop, rest two of them are SR flip flop. Okay, we do not need a additional inverter, is not it, to convert it to D, because directly we can connect and then we can internally, and we can get the shift register action performed, right. Okay. So, and A is, when B is 1, say the control input is 1, then A, whatever is the value of A, the data that you want to put in the registers, this group of flip flops, that will be passed through A, and we will get to the get to those flip flops through clock trigger. Okay. And these A and B, they can interchange their role. One can become the control input, the other can become the data input. Okay. And we have got a asynchronous reset, okay, which is active low and common one. We shall see how it works and all, and also a common clock. Okay. So, this is the way the circuit behaves. And now, you can understand that while this is your serial in, say in through one of them, and you can read the data out other than parallel data output through QH also as a serial data out, because it is internally connected as a shift register, one is feeding the other. So, if you keep triggering the clock, so whatever is QH is immediately available. After that, QG will become available here. After one more clock, QF will be available here. After another clock, QE will be available here. Okay. So, that way also you can read all of them by triggering of the clock, but it will require more number of clocks, and you already have the option of parallel reading. Okay. But to know that, it is also possible to serially read it through QH. Okay. Fine. So, let us see how this serial in and asynchronous reset work in this particular IC. Okay. So, we have given an example here. So, this is your clear, right. So, whenever this is asynchronous reset. So, whenever you are giving this clear, okay, so it will become all set. Okay. So, clock start triggering, over here, and at every positive edge of the clock, you can see from the truth table, it is positive edge triggered, okay, and also you can see from the circuit that it is positive edge triggered. So, every positive edge of the clock, it gets a trigger, okay. But as long as B is 0, we consider B as the control input, right. Then even if A is high, that is not getting transferred to the output, okay. So, at this positive edge, okay, whatever is the value, it will remain the same. So, that there is no change. When B becomes high, okay, the control input becomes high, then whatever is the change in A, that can go to the flip flops serially one after another. So, we can see this is one positive edge, right, and when after clock has become control input B has become high, and at that time at this edge, the value over here is 0 for A, okay. So, QA will get 0, that is what it has got. So, next clock trigger, before this clock trigger, again A is 0. So, QA will get 0, and before this clock trigger, you see the value is 1. So, now after that clock trigger, QA has become 1. Is it fine? Okay. So, similarly over here, this becomes 1, and just before clock trigger, you see it has become 0. So, it becomes 0. Before this clock trigger, this is 1, after that it is all 0, okay. So, these are all 0. So, this is how it would look like till the next reset comes, otherwise it is 0, okay. When it is there, reset comes, asynchronous reset, immediately irrespective of the clock trigger, you see the clock trigger comes over here, it was here, again it comes here, but it will become immediately 0, okay. This effect is not very pronounced here, but you will see for the other cases, okay. Now, what happens to QB? So, QA is fed as output of A is fed as input of B, right. So, this 1 up to this is 0 0. So, 1 will come over here, 1 will come over here, 0 will come over here, and 1 will come over here. Is it okay? So, this is the way it will proceed, and finally, you can see that this is 1 1 0 1 for QE, and after that QF becomes 1 1 0 0 like this, okay, and this becomes 1 1, and it could have been 0 and 1 unless this asynchronous reset was there, and similarly for this one. So, whenever this asynchronous reset occurs, all of them become 0. After that, when a clock trigger comes like this, the reset has moved. So, as long as it is reset, this line it will remain 0. Okay. After the reset has moved, so it has become inactive, right? It has become high. So, next clock trigger is here. So, at this clock trigger, all the inputs are 0, right? So, the outputs are 0. Is it okay? So, this is how the serial data in comes, and output you can read from QA to QH parallelly directly. Okay. And in the truth table also it is mentioned like this, QXN whatever is the value. So, QB takes the previous value of QA in the with the clock trigger. Okay. QH takes the previous value of QG just before the last clock trigger, whatever value was there, that is taken. So, this is how you have to read the truth table, and corresponding timing diagram would appear in this manner, and also you understand the how asynchronous reset works. Now, let us look at the other variety, parallel in, serial out. Okay. So, again we take up an actual circuit, practical circuit which is in use, which is IC 74166. Okay. So, in this what you see, it looks a bit complicated. Slowly we are moving into more complicated circuit. The first one we saw is parallel in, parallel out, but then you see that because it provides little bit of additional control operation. So, what is it? So, this particular block if you look at it, okay. So, there is an inverter here and there is an inverter over there. So, if you put them together, basically it is a SOP realization that you are having. Okay. So, this SOP realization, if you look at it for SA, okay. So, this is shift here ANDed with serial in. This is your serial in. Okay. Do you get it? So, shift here ANDed with serial in, I consider this is shift, forget about the load part of it. Okay. And then shift prime. So, this is coming over here, the inverter ANDed with A, that part is understood. Okay. So, what does it mean? When a clock trigger comes, at the input of the S flip flop over here, SR flip flop over here, okay, and R is just taking the invert of R S. Okay. If shift is equal to 1, serial in will be going as the input of SA. Okay. And if shift is equal to 0, okay, so 0 bar, so this is 1. So, A will be going as input of SA. Is it clear? This part you understand? So, that means with clock trigger, with shift is equal to 1, serial in will come here and clock is equal to 0, the value A will get loaded. Now, come to flip flop B. So, this is SB. Okay. So, what is happening at the input of it? Shift, whenever it is 1. So, this is the shift is equal to 1. So, this thing. Okay. So, then QA is coming to the input of SA, and when shift is equal to 0, B is coming to the input of SA. Okay. So, what does it mean? Whatever was the output of QA becomes output of QB after the clock trigger. So, it is getting shifted, value of A getting shifted to B. Okay. Flip flop A value is getting shifted to flip flop B. Is it fine? And if shift is equal to 0, then this is getting loaded by the parallel in that is there, which is B. So, similarly over here you can see. Is it okay? So, this parallel in serial out and serial out is coming, you are taking from finally QH. Okay. So, you can put it parallel in just by simply loading it using this input control input to be 0, and then for reading it, since there is no parallel out available, okay, because there are 8 flip flops, then you will require another 8 output pins which is not there. Okay. So, you have to read it from here by triggering the clock, which as such will be destructive, but if you have a feedback and other mechanism that we should discussed before, okay, then it will be there can be a non-destructive reading. Is it fine? You understand how it works? Okay. Now, we look at what is called universal shift register. So, we had seen 4 varieties, parallel in, parallel out. Okay. So, this is the one, then serial in, serial out in last class, and in today's class serial in, parallel out and parallel in, serial out. Okay. So, in the universal shift register you have all these options available, right, and of course, when you make all these options available, the sacrifice will be the number of bits you can handle within a particular package. Okay. So, that is another part of it, but if you require a versatile device to do which can perform many different operations, okay, shift right, shift left and all those things, yes, in this connection you need to remember the universal shift register offers both left shift and right shift. Okay. So, that means data can have a left shift, that means if it is A, B, C, D, this is the way the flip flops are organized. So, data can come to QD, then QC, QB and QA, this is the way it can be shifted with clock. Okay. or it can have write shift where data is coming to QA this and then QA goes to QB, then QC and QD. Is it okay? So, this is the bidirectional shift that is possible in universal shift register. Okay. So, let us look at again a practical circuit which will help us in understanding how it works, and we shall look at inside circuit as well. So, you can see this is IC 74194, right. It has got S1 and S0, two control inputs, right, not one. Earlier shift load there is only one control input. So, these two control inputs between them offers four possible options, 0 0 0 1 1 0 and 1 1. Okay. So, for 0 0 we expect certain operation 0 1 something else 1 0 and 1 1, right, and this is depicted in this truth table. We shall have a more compact and easy to understand version of it in the next slide, which I shall discuss shortly. Okay. So, what else is there? So, parallel in and parallel out, you can see this is parallel out, because that option also need to be made available. It is universal shift register, okay, all possible things. Then shift left serial input and shift right serial input, both the things need to be that can have bidirectional shift, okay. And other than that you have got clock and a asynchronous reset, active load, clear, and of course VCC and ground, and it is a 16-pin package. Is it okay? Right. So, let us see the circuit and how the truth table looks like in a compact manner. So, for S1 S0 being 0 0, then there is no change. Okay. S1 no change means whatever is the value it will remain the same, right. If there is it is 0 1, there will be right shift, 1 0 this is left shift, and 1 1 parallel load, okay, because parallel in that is possible and parallel out is always there, because you have seen QA, QB, QC, QD, those outputs are there. So, this is the way the control inputs play into the circuit. So, you look at this circuit, because not all 4 bits are shown, 2 ones are shown, but from that we can understand how it works. So, first of all again the way we had done it for another shift register, another IC. So, if you look at these outputs, so this is your NOR, that is there is a bubble and there is a bubble. So, effectively it is a AND or SOP realization that you see here. And if you try to write it in the form of a Boolean equation for A, okay, so this is your QA, so this is flip flop A, right. So, this is how it would look like, right. So, if you look at this way, so S1 prime, S0 prime, so S1 is here, so S1 prime is this one, this line is S1 prime and S0 prime, okay. So, this line is S0 prime and this is your QA. So, this is S0 prime, this is S1 prime and this is your QA. So, these are the 3 inputs, okay. So, that is what you see as the AND output, which is ORed with rest of the inputs, okay. Similarly, S1 prime and S0, you can see this is your S1 prime, you can see drop down from here, and S0 there are 2 inverters over here. So, this is your S0 and that is ANDed with serial in, shift right serial in, okay. And then S1 is 1 and S0 is 0, okay, S0 is 0. So, this is the case, it happens S1 is 1 here, S0 is 0, this is the case, these 2 points that is coming down over here. So, this is this AND gate we are talking about, okay. So, in this the input is coming from the previous stage. So, that is QA, so it is previous stage is QB, so it is coming from QB. And finally, here S1 and S0 both are 1. So, this is the case, this is the AND gate. So, in this case A is coming over here. Is it clear? Right. So, if this is for happening for SA, for SD, the other case, you can see the first one is self loading. I mean, this its previous value is loaded. So, that is the no change case. So, S1 and S0 both being 0 0. The second case shift right. So, earlier it was serial in this case it will be QC, it is coming from it is right shift. So, QC will be the input of this one, right, and for S1 being 1 and S0 being 0, right, this was QB here. So, the it is a left shift operation, from QB it was coming to QA. Now, there is no other flip flop after this. So, basically then you have to consider serial data in, which is for left shift, that was there in the IC, one of the input. Okay. So, that is what is connected here. Okay. And finally, when both of them are 1, D is directly getting loaded, parallel load is there. Is it fine? Okay. So, this is replicated in the rest of the cases with in the appropriate values of here, other things are similar, right, and this is asynchronous clear, and and clock is common to all of them, fine. So, now we understand how this universal shift register works, but one IC that often are used in the lab is IC 7495 or 7495A, okay, and it is not a universal shift register. If you look at the built-in things that are available, unlike the previous one that we just discussed, okay, but we can make it work like a universal shift register by external connection. Okay, since it is often used in the lab, and so I have taken considered this as a topic of the discussion. So, let us see how it actually looks like, and so this is a 14 pin IC. Okay. So, 4 bit information can be stored. So, ABCD is the parallel in, and QA, QB, QCD, QD are the parallel output that you can see. Okay. And here you have got one control input, mode control. Okay. So, when mode is equal to 1, it is a parallel load, and when mode is equal to 0, it is right shift, it is right shift. Okay. So, this is the way it has been configured, and you can see two clocks are there. One clock is for right shift, that is there. The other clock, okay, over here you see it is written left shift within bracket load. So, the other clock is actually used for this parallel load, which can be also used for left shift operation. So, how that left shift which is not built in, we shall see how to get it done. Okay. So, this is basically what is there, and now we will look at the circuit. Okay. So, this is again made through SR flip flop, and so this is the mode control, right. This is the serial input, and if you look at just one of them over here. So, in mode is equal to 1, okay. So, 1 comes here. So, this is your 1, okay. This is 1, this is 0. So, another inverter. So, this is 1. So, this AND gate is now active, the other AND gate input will be 0. So, this will be 0. So, this is again a SOP kind of thing, because of two bubbles, two NOT gates are there. So, it is AND or SOP realization. So, at that time this is 1, right, and D. So, D comes as the input. So, it is parallel load that is happening. Okay. And for the other case, when your mode is equal to 0, mode is equal to 0, okay. So, you can see that this is your 1 and this is your 0. So, this AND gate output will be 0, and this is this AND gate, the other AND gate, it is taken from here, this inverter output. So, this is your 1, okay. And then at that time QC is coming over here. So, this is QC, right. So, QC will be over here. So, QC output will go to the QD. So, basically it is a QC is going to QD. So, similarly if you look at the others, QB will go to QC, QA to QB, and for QA there will be serial input in. So, this is the serial input in for mode is equal to 0, okay. So, this becomes 1. Is it okay? Right. So, that is your write shift operation, and at that time when mode is equal to 0, right, mode is equal to 0, you can see that this clock is defunct, okay. This clock is defunct, right. At that time this is 1. So, this clock is write shift clock is functional, okay. So, write shift clock is functional, and when mode is equal to 1, mode is equal to 1. So, this is 0. So, this is 0. So, this write shift clock is non-functional, okay. So, at that time this is 1. So, this so called left shift or parallel load clock. So, right now we have seen parallel load only, do not worry about the left shift part of it, okay. So, it is just doing parallel load, okay, through this clock at the trigger of this clock. Is it okay? Now, let us see this popular IC 7495, how it can be used for left shift also, okay. So, for this we need external wiring, okay. So, you see how the external wiring is done. So, you see this thing, this is external wire. So, QD is connected, this wire is going here, it is coming here, and then over here as input to C. So, instead of C, so C is the output, parallel load C is the input, parallel load input was there for C QC. So, QD output is now connected as at the input of C. Externally you connect this wire, okay. Similarly, QC is connected to B input. So, parallel load input is there for the flip flop. So, B. So, QB is connected to A, right, and QA is there as the final output, okay. So, serial data in will be coming through D and serial data output will be through QA, okay. So, how it is happening? So, the mode control part we have already seen. So, basically when it is 1, right. So, then this flip flop, this AND gate, okay, this AND gate and this AND gate. So, they are active, and the other AND gates, these outputs are all 0, okay. These outputs are all 0 because it is coming from here and this is your 1, okay. So, at that time at the at this particular clock, okay, so left shift clock, so which is coming here, this is 1 and this is the clock we are talking about. So, this is 1 and this is the clock, and the other case this is 0. So, this is not working. So, this is this AND gate output is always 0. So, OR gate output will be taking this AND gate output. So, this clock will be the one in consideration. So, at that time you are having your this QD getting loaded through C, okay, to flip flop C. QC is getting loaded through B to flip flop B, and QB to flip flop A, and QA is available as the final output, okay. So, this is the way the left shift operation takes place, okay. So, it is not built in, but it works in that manner, okay. So, we got an idea of the register and the parallel in, parallel out and different kind of shift registers, that is SIPO, PISO and SISO in today's class as well as the previous class, as well as what is in the making of universal shift register. So, last week we saw flip flops as individuals, and in these two classes we have seen them as a group storing binary information, and we have seen how to read and how to write for these different configuration, okay. And with this we move to next class. We shall see the applications of shift register, other applications of shift register. Thank you.